So I got a question from one of the viewers, and they were asking, what is the difference between using the square bracket notation to initialize and instantiate an array and using a pointer to actually initialize a dynamically allocated array? Can't you use one over the other? Well, let's find out. Here I defined two arrays that are basically the same thing in terms of memory, right? We have here an array of 3 elements, but all of them being 1, 2, and 3. And here I have another, well, array, or just some block of memory that's been dynamically allocated, and it also has 3 integers. All of them I've initialized to 1, 2, and 3. So what is the difference between this array and this one, other than the fact that this one is actually dynamically allocated? Well, behind the scenes, they are both 12 bytes array in size, right? We have 3 integers, and each integer is taking up 4 bytes. No questions asked there. They are basically the same behind the scenes. Then what's different? Well, the difference comes from the way we are referring to this, right? In one instance, we're referring to this array using an array identifier, right? That's the type of our variable. In the second instance, with the dynamically allocated array, we're actually using a pointer, right? Can we use a pointer to refer to a statically allocated array? Of course we can. We can simply say here int rp, let's say, star equals r, and that would simply convert our, and that would simply decay basically our array to a pointer. So it has the property of implicitly converting or casting to a pointer, right? So now, what are the actual differences between these two, really, and what you can and what you can't do with them? Well, the first difference is that you cannot use the square bracket notation to define dynamically allocated arrays. Why? Well, that's because what I used here is actually a sort of syntactic sugar, right? Behind the scenes, what the compiler actually does is add here a 3 and says, all right, here give me 3 integers, right? And due to it having this sort of way of defining your variable, you have to give it the size. Thus, this type of notation has the property of allocating memory, right? So this guy automatically allocates 3 integers in your stack, right? It cannot allocate it automatically on your heap, right? But a pointer doesn't allocate memory by itself. Of course, it's gonna have some memory allocated for it, those 4 bytes or 8 bytes for a pointer, depends on your architecture. But the array itself was allocated by us calling malloc, right? So that's the main difference. So the first one allocates memory, right? So however you give it here, it's going to allocate, and the second one doesn't do anything. It only points to some memory that you give it, and I'm simply giving it the pointer to our dynamically allocated array that we have actually allocated. So I try to print to the actual addresses to which the array starts, right, inside our own memory. So if I try to run this, I'm simply just using %p here to print an address, right? You'll notice that they are just normal, simple addresses, right? The first one is our array, and the second one is our dynamically allocated block. You know that pointers have this property that if you add to them, they add 1 times the size of int. So this happens with our pointer as well. So if I try to p equals p plus 1, that would add, well, 1 times 4, because integers are on 4 bytes usually. So we get, well, whatever address we got to the, well, whatever address we got from malloc, and added 4 bytes or 4 to that number. If I try to compile this, you'll notice no problem, we can even run this. But I'm not going to do that, because here's the main difference. If I try to do the same with our array, considering if, well, for some reason it might behave like a pointer, if I try to compile it, you'll notice that I get assignment to expression with array type. Basically, I cannot assign another value to our array. This assignment didn't really assign a value to our array. What it did is simply said, whatever I did here with RP, just with the array, but in one line, so that it's simpler to define, just syntactic sugar, right? The compiler still will compile it to something like this, right? So those two are basically identical. If I try to run this, well, still the same thing. I cannot assign it any sort of value. But that's because it's an identifier, and that's because we're using array. Can't we really get a pointer to our array and assign it? We can actually, we can. So what we can do is, instead of having just our array, we can say, all right, int star, int pointer, let's say our array p from pointer equals, well, just array, right? What happens if I try to actually add to this pointer, right? And also let's try and print this this little guy. If I try to run this, you'll notice that we get basically the same value, except one is 4 bytes over, because we've added, remember, we've added 1 to this. If I don't actually add anything to it, well, we don't get anything added, right? So we can actually get a pointer to our array the same as this pointer, right? Except it's just the way we're defining it, the way we're referring to it. We say, okay, array, just ARR. If we just say that and we try to assign it, our compiler won't let us do that. So wait a second, we actually just assigned the pointer's value to be our array. Why can we do that? It's confusing, right? Not so much, because the array itself can actually behave like a pointer if you just use it as it is, right? It can just simply decay to a pointer, and since this is a pointer, this is considered a pointer, right? It's going to let our program assign its address to this pointer and just continue on with the execution. So no worries there. Same thing if you try to actually pass it through a function. If I try to, let's create a function here. So here I have a function, and if I try to just call this with our pointer, so just example of p, simple as that. If I try to compile this, well, nothing happens. Everything's fine and dandy. We just call that function. If we try to do the same with our array, well, same thing. We can simply use it because it's going to decay to a pointer. And now this pointer, actually, we can now modify it. We can just say L equals L plus 1, right? And it won't actually give me a compiler this time because we've actually copied over the address, right? This guy decayed to a pointer, and then it got passed to our example function, right? And when it got passed, well, we actually just got a pointer, not an array identifier in here, right? And that it's fine to actually assign to. We can assign as many times as you want. Now, I hope you understand now a bit about the difference between array identifiers and pointers, right? They are similar, but not quite. It's just different in the way we refer to it. And due to the way it's defined, it cannot be dynamically allocated. That's why you have to use malloc and a pointer to actually allocate a dynamically allocated array. Okay, one more thing before you go. Here's a pretty cool feature, I think, of array identifiers. If you ever stumble upon needing to do something like this, is if you want to take the size of this array. If you want size of array, and if you also want size of p here, if I try to run this, you notice I'm just printing out the actual sizes of our both array and our dynamically allocated array, right? Percent %LLU just says print a long unsigned value. That's what size of returns. So if I try to run this, you'll notice that they give some different values. One gives 8 and the other one gives 12. Why is that? Because the 8 is pretty obvious, right? P is a pointer. And my machine and my compiler are both 64-bit, right? So pointers are of 64 bits or 8 bytes. So what do you know? You get 8 here, right? But when doing the same thing with our array, we actually get 12. And that 12 is for this number times the size of integers, which is 4. So 3 times 4, that's 12. If I change this to, I don't know, 20, well, we get 80. And that's exactly how much memory you've allocated. Due to them being array identifiers, you can actually know their size. Now, I'm not sure this is 100% compatible with all compilers, but it's a neat feature if it works. Alright, that's about it. Thank you guys for watching. Keep on asking questions down in the comments below. And, well, see you guys next time. Bye.